Alright, so I was gonna make this a diagram for members, but I don't have any. So I'm gonna make a bonus video instead. That should work out. So right now the power supply is 11 volts, and this is not a very energy efficient circuit. We got about 13 milliamps going. So we have the blue LED lit up right there, and the goal for this is I set a voltage with a diode right there, about 0.7 volts approximately. We also have some hysteresis though. So what we can do is at this 11 volts, for a future video, this is a important voltage for me. So now you can see I adjusted the trimpot. The output changed, and I'm going to turn the trimpot. This is a multi-turn trimpot. You turn it, I think, like 30 times or something to go one end to the other. So the voltage is very slowly changing. But we hit that point right there where the blue LED lit up. So now we're going to zoom way back right here, and I have hysteresis, as I said before. So we bump up to 12. You can see the red LED lit up, and if I work my way up though, you can see it stays blue until we get close to 12. Looks like we had to actually hit 12. Now, it didn't go right back to blue. This is the hysteresis right there. And so it's going to change back to blue when we hit 11. So we'll look at this circuit in more detail later on. So now we have an op amp over there and some other stuff, but the two main players are these two circuit fragments right here. So we have a reference voltage. We have a forward bias diode right here, that just a rectifier diode that is behaving kind of like a Zener diode. Zener diodes are specially made reverse bias. They build up a certain Zener voltage that you use as a signal in the same way. But here, we're just taking a forward bias. When current's flowing through it, it builds up about 0.7 volts approximately. And so it could be like between 0.6, 0.7 volts. But it stays really steady, just changing slightly with how much current is flowing through it. So I want to work with higher voltages. So what we're doing here with this resistor, we can get up to 14 volts that we can put across this. 1.5 kilo ohms is the same as 1,500. So we got that diode drop right there, the voltage difference. This is just a signal, and something looks at the voltage. It doesn't affect it. And so we have the diode drop about 0.7 volts. So we got like 13.3 volts left. Divided by 1,500 ohms equals a 0.00, basically 9 amps right there. So like 9 of that milliamps we saw before was just going through that diode, actually slightly lower. But in case at 14 volts, that's how much current will be flowing. As I said, this isn't energy efficient. Now with that current times that voltage, you get how basically hot that resistor is going to get, the wattage. How much heat it's going to generate. It's rated to dissipate 0.25 watts. You want to stay below half of that, and we have that right there. So that's why I set the limit of 14 volts. Now we have the trimpot. It's a 10 kilo ohm, 10,000 ohm trimpot multi-turn. So it barely moves as you turn it, but it does. And so 11 volts, we had to set it very low to get it to drop down to 0.7 volts, but you can. So right when you saw the blue LED flip, that's when we dropped it down, if it was 0.7 volts, right below 0.7 volts. And then when we raise the voltage though, that's a percentage of the supply voltage that we got. So at 11 volts, if it's 0.7, and then you start raising the supply voltage, it's going to inch the voltage up. It's still going to be a small fraction. It's not going to go as fast as the supply voltage goes up. But it's going to inch up, and if you're right at that borderline, it can flip the state of the op amp because it's comparing those two voltages. So hopefully that makes sense. So now I have the multimeter probes. There's alligator clips there. I crimped jumper wires to them, and so the red one, it's off to the side there, it's going to where the diode is, as we said before. It's a voltage divider. This resistor also goes to there, and it's really warm. I shouldn't have touched it, but I didn't really get burned too bad. So that looks like that's the voltage we got built up across it. So first we'll zoom back, look at the supply voltage. I said that we could go up to 14 volts, and you're going to see that it does change a speck, but it's hardly changing. It's basically the same voltage, you know, changing slightly, but holding, you know, relatively steady right there. We dropped, you know, 12 volts right there, and it's still between 0.6 and 0.7 volts. That's the main thing. So now we're going to go back to 11 volts, and so that's where I set the trim pot. But we have hysteresis, which may throw it off, and if it gets confusing, I might move our hysteresis resistor. But there you can see it's about the same voltage right there, and so when we go up to 12, you can see it bumped up a whole lot. Now it's higher than what we have, and we have this wired as a comparator circuit. It's comparing those two voltages, and when our trim pot voltage gets higher, then we're going to get a high output. You can tell it's high because it's red. When it's lower, then we're going to get the blue LED. So it's higher now, and it's going to keep going up as we raise it. But there you can see it's drastically changing as I lower the voltage, and so it's still a fraction of the supply voltage there, so you know, not super rapidly changing. It's not jumping up near 14 because we got it set so low, because when we got 11 there, you know, this is what is that, you know, like 5% of that voltage right there. So it's going to stay, you know, in that range, you know, approximately 5%, somewhere in that area of the supply voltage. Now, I think I demonstrated this kind of before, but we set this to 12 volts right now. Now, I want to make it where 12 volts is where this will go blue instead of red. So I'm going to make the adjustment, and it's really easy. So again, this is a multi-turn trim pot. You turn it many times, and so now I'm going counterclockwise, and you can see the voltage rising right there. We have feedback though, so the output's high. It's help raising that voltage a little bit, and when you see the LED go blue, then it's going to drop a bit from where it was. And thought it would be blue by now. Going the wrong way. That's the problem. I'm going the wrong way. Alright, so that happens sometimes when you're adjusting. I'm going to leave that as a blooper. Okay, there we go. We got it blue. And so now I'm going to go up till it's red. Remember, there's hysteresis though. And so I didn't have to find that direct spot. And these slip off the screw pretty easily. So I'm not going to edit this down. I'm going to show you, you know, it's kind of a pain to do this, but not too bad. So right when it turns blue, then I'll know I hit the point, right, that I want to be at. There we go, blue. And so now we got it set where it's like 12 volts. So we could have got rid of that hysteresis. It would have simplified things. But in any case, now you can see at 12 volts, it's going to go blue. And again, it should be about a volt before it goes red. So probably like 13 volts it'll go red, and yeah, looks like pretty close to 13. I was watching the LED and not the voltage as much. So let's try 13 again, and nope, slightly different, but again, it was about a volt of hysteresis. Alright, so we'll kind of wrap this up. As we talked about before, this is getting us a reference voltage. So you can see that we got the I used a lot of 1,500 ohm resistors in the circuit, and again, it's hot. I shouldn't have touched that, but there you can see it comes across to where the diode is, and it is forward bias. That's the direction it conducts easy. If we put it backwards, it's going to have that full voltage because it's not going to let any current flow through it. So as the current flows through it, it still builds up about approximately 0.7 volts. And so this is our feedback resistor right there. So it's going to the non-inverting input, so it's positive feedback. So it's making the trim pot voltage more like the output. So it's a 100,000 ohm resistor, but as you saw, it was pretty effective in this circuit. Without this, right when we waver to that you know, approximately 0.7 volt point, whatever we had right there, right as we waver it, like if it like wiggles a little bit for whatever reason, these sometimes it looks like both LEDs are on. They're actually bouncing back and forth just really rapidly switching. So this gets rid of that. If you lower this enough, then the output goes low and it pulls the voltage down a little bit more. And then so you got to raise it up a little bit extra to get that higher voltage to set the output high. And when you do that, it's going to bump it up a little bit so that, you know, you have to work your way back down farther again. So stuff I covered in other videos, and I'm going to do this whole circuit in a later video, but I figured I would do the bonus video. As I said before, I don't have members. I was thinking I'll just, you know, draw diagrams like this, extra stuff for members as a reward. But in any case, hopefully you like this as well. So thanks for watching. Check out the links down below. They all help out a lot. I'll see you in the next one.